Okay, today we're going to be beginning our respiratory system, and we'll start off with a little bit of an anatomy review. So the respiratory system, let's just start over here. It functions in ventilation, which is air movement, and this is due to a change in pressure. O2, CO2 diffusion. If I can spell it. This is at the alveolar, which we'll talk about in a second. This is a change in the concentrations of oxygen and CO2, getting the actual oxygen to the working tissues and removing CO2 via the bloodstream and blowing it out via expiration. 3, respiratory is functioning in the distribution of gas and blood, and this functions. Let's see, any alterations in blood pressure is going to be the mechanism that moves that around. 4, respiratory system is also important with the diffusion across capillaries. I can't spell this morning. And then lastly, it functions in cell respiration, using oxygen as the final electron acceptor and producing large amounts of ATP via that mechanism there. Okay, so now we've talked about that. We've got our person here. Let's talk a little bit about some of the major anatomical functions here. We have a nasal cavity where the air is warmed, comes in through the nose. So we have O2 in, warmed here, comes down the pharynx. Inside the nasal cavity, we have goblet cells that produce mucus to help catch some pathogens. We have the oral cavity here. Over here we have the laryngopharynx. The vocal cords live in here as well. And our trachea, which is covered in smooth muscle so that it can bronchodilate and bronchorestrict or constrict. Then we have our left lung over here, and our right lung over here. Remember, our left lung has 2 lobes, our right lung has 3 lobes. And let's see if we missed anything. Our laryngopharynx, our larynx, trachea. So as the air comes in, it follows through it enters into the nasal cavity. If you're a nose breather, some goblet cells are going to secrete some mucus, and they're going to catch some of the pathogens. The air is then going to travel into the pharynx, and in the pharynx we have some cilia. We have some cilia that line that too. So in addition to the mucus that's produced at the goblet cell to help catch some pathogens, we also have some cilia to keep some of the cooties out as well. And then we go past the vocal cords, and then we enter what we call the conducting zone. The conducting zone is the trachea, and then where the air is going to enter the lungs, and the right and left bronchus. So this is the left bronchus, right bronchus, and like I said, we go the bronchus, and then we have ending and terminal bronchi over here. But we'll use the right lung as the example. So eventually, though, we get our conducting zone, and we eventually enter into all of these branch tubes. So the bronchus starts branching out like this. And a whole bunch of different tubes inside the lung. And then once they finally enter all these tubes in the lungs, they end up in, let's just draw a whole bunch of sacs called the alveolar sacs here. So these tubes end up in here. And around all the sacs, there's a high level of blood supply via capillaries. So we'll have our red, the capillaries surround the alveolar sacs, and then this returns to the heart. And it's going to enter into the left atrium, then left ventricle, then aorta. However, we also have some removal of our CO2 as well. So these are blue. These are veins. And this is going to be CO2 from the right ventricle. Or I should say these are our veins. Actually, in this case, it's our pulmonary artery since it's leaving our right ventricle. But it's deoxygenated blood, and it is coming in here to have CO2 release, so CO2 could be blown off out here, because CO2 is going to come out this way. So we have all of this. This is our respiratory zone. So it follows this way. Air enters in the nasal cavity or the oral cavity. Mucus protects it via the goblet cells, helps catch all the pathogens. The air enters into the pharynx, protected by some cilia. It enters into the conducting zone once it passes the vocal cords. The conducting zone is just a low resistance pathway. It contains cilia, mucus, macrophages to help keep things out. It warms and moistens the air as it comes in. And then we enter the conducting zone through the trachea. We're going to enter the lungs via the right and left bronchus. And there's two tubes here. That's important to keep. As we enter the bronchi, we get 4 to 8. And then we get bronchioles. There's 16 tubes on each side. They're surrounded by smooth muscle, which can dilate or constrict. Finally, we get to the terminal bronchi. And there are essentially 32 of these tubes. And then we get to the respiratory bronchioles. Now we're in the respiratory zone. This is where gas exchange actually happens. And then we have 5 times 10 to the 5th power number of respiratory bronchioles. Finally, we end up in alveolar ducts, which conclude in alveolar sacs. We have 8 times 10 to the 6th of alveolar sacs, approximately 300 million alveoli. If we were to stretch them all out, it would be approximately the size of a tennis court. So that's how the air comes in. Once the air enters into the alveolar sacs, surrounded by the capillaries, CO2 and O2 can be exchanged in the lungs and then passed into the bloodstream from there. So lastly, our respiratory system functions in getting oxygen into the bloodstream, removing CO2, maintaining our pH via our hydrogen ion concentration, and this is done at the kidneys, helps form speech, and also with cilia and mucus keeps out some foreign invaders.